Hello, everyone.
Hello,
Hello.
we can hear you.
Good afternoon. Can anybody hear me or
Yeah, we can hear you.
Yeah, we can hear you, sir.
Oh, thank you. Good afternoon, everybody. My name is Tariq Alwan. I'll be your lecturer for the next few weeks. Let me first wish you all the best, not only in this unit studies, but for the rest of your studies as well. What you will study with me exactly the term. In the prerequisite unit, which is the IT infrastructure, the fundamental unit, the 238, you have studied the OC layer. However, we just gave you at that time heads, titles, basics. We haven't gone deep down into deep details. What we will do in this unit, we will go over the OC layers. However, in some parts of the layers, we will start diving deep down into some high-level areas. So what exactly the goal of the OC layer? What's the main goal? Well, the main goal to explain how if I sent a data from guest A to a device B, device A to device B, what happened exactly from the time we hit enter? What's going on from the time I hit enter until it arrived to the other side? That sounds easy. It's not that as easy as it sounds. So what happened exactly? If I want, for example, like here, a device A to communicate with device B, what they need to do exactly? Well, similar to human being. If you want to talk to someone, you need to have a common language. The common language within devices, we call that protocols. Anybody remember what is protocols? Anybody remember what is protocols? True. That's a set of rules and controls. Rules which tell you what to do, when, how, and so on. So for device A, like client, the client you see in my screen right now, to be able to communicate with the server, they need to have to come into a common language. Those ones we call it protocols. Different communication require different protocol, which is different language. So let's see that if a client want to communicate to a server, what usually happens? Let's take an example from my side. Assume that's me, and I want to communicate with the server. Let's say that I want to buy something from Baidu online. What happened exactly here? Well, let's see. Let me demo that for you. You may be, that's HTTP www.baidu.com, right? I'm gonna minimize that little bit so you guys can see that in the site here. At the same time, I'm gonna go over here. I'm gonna run the Wireshark, and I will choose here. I will filter with HTTP, and I'm gonna come back here and I will hit enter. So what happened exactly here? Let's minimize that. We don't need that anymore. So what happened exactly here? Let's go. This is the Git. Can you see the Baidu at the bottom here? What that give me? Oh, it gave me the source, the destination. The source at that time, which is my computer, my device. That's my IP address, which is 192, the 202. Then it gives me the destination, which is the remote server, which is 103. Okay, what is the protocol being used? That's HTTP. And the version 101 and so on. We can get into an extra details. Over here, what is that? That's the reply back from the remote server, which is Baidu, to my computer. What's in over here? That's the reply back from 103 to my computer. 200 OK, which is the code, which means that you got what you have a successful pitching. So what are these ones? What are that frame? I'm not sure how many of you actually have seen or you have experience with Wireshark, but why have frames here and some details are under? The Ethernet. Okay, that's from what I see here, that has something like a MAC address. Okay, what about that? That's an IP addresses. Source and destination, that's the source. Then over here, I have ports. So what exactly giving me here? That's similar to the layers. This is layer number 4. This is layer number 3. This is layer number 2. Let's save this one for a while because we will need that later on. I'm gonna keep that here. Then we go back to the scenario. What happened here between the client and the server? Yes, usually. In reality, what we have here, we have what we call that the internet. What is the internet? Well, you have studied last week the internet working. The easy definition for the internet, networks of network, a network of networks. What that a massive number of interconnected networks. However, for the sake of this lecture today, let's ignore that what's between right now. So now the client and the server, they communicate directly, which means that we call that one set of client server. So the client here communicate to the server reply back with the ignorance of the internet. Okay, what about if I send an email or you send me an email? What happened exactly? So for example, if I tried This is me, let's say. I'm using Gmail or Hotmail or whatever you like. And this is one of you guys, or all of you. For example, I want to send you an email for the CQ server. No problem, like your email. So what is usually happening here? Well, here it is. We're using SMTP, the protocol which send the email. You type your email here, or I type here inside the agent, which is the platform of Gmail. So I'm typing the email here, then I send. The SMTP protocol take it to what we call it a mail server. Which mail server? The Gmail server. That's one. So that's the agent transfer that into the mail server. Then the mail server, which is Gmail server, search for the CQ mail server and send it here, cross-ensure the internet. That's another client server because this one will act as a client. When it arrives here, usually the CQ server will send you an alert that you have received an email. And it's up to you, your agent or platform or whatever you call it, you want to call it, it's up to you right now to log in and get your email through the agent using IMAP or POP3. It's up to you, whatever it is. So there is no direct between my client directly to the receiver from the sender to the receiver. There is none. So you have to send it. I have to send it to my email server. My email server contact your email server, and your email server then contact you to use the agent to download your email. We have here 3 sets of client server. That's number 1, that's number 2, and that's number 3. Okay, so is not all the time client server, one set of client server, is not. So how they communicate, and that's the main goal for the whole unit. How they communicate? Well, they go through what we call it layers. What layers exactly you talking about here? We need to go through those OSA layer or TCP IP layer, the 5 layers. In the prerequisite unit, we did cover with you that every layer has services and functions and includes some famous protocols. So for the email here, that email has to go through what? Oh, this is the application layer. Yes, the application layer can communicate with the application layer in the destination. The transport can communicate from the sender to the receiver. The network can communicate with networks, but can they communicate directly like that? No. What they do exactly, they have to go, the source or the sender has to send the data from the application to the transport, from the transport to the network, from the network to the data link layer, then the physical layer in his own device and through his site. Then those ones pass through its own or his own LAN through the switches. That's the LAN. Then cross to the WAN, which is, it can be one router, it can be many routers. It depends on. Then arrive to the destination LAN. From the destination LAN to the device, the destination device. The destination device go through the opposite process from the physical to the data link layer to the network layer to the transport to the application. How to visualize that? Let me show you how that being visualized easily. That's the message you want sent. We add to, as you can go through, can you see that? We add what we call it headers. What are those headers exactly? At that time, I'm gonna take you over here to go back to what we call it encapsulation. What exactly that encapsulation? What you see here is like this. Assume that you setting, let's take an example. The 7 layers, which we have, as you can see that, we mentioned to you in the first lecture that we have 7 layers. Each layer has functions, services, and protocols, famous ones, the venues. The top layer, which is the end user layer, the application layer, that's end user layer. What is the job for that? The encoding, usually that has it, or the format, what we call it formatting, the encoding. That's the main function for that. And that's the end user layer. So, which has attached to it very famous protocols, HTTP, HTTPS, ICMP, SMTP, POP. You have DNS, which is very important. For now, if you know Telnet or SSH, whatever, it's okay. If you don't worry about that for now. But the email protocols, the HTTP protocol, the DNS and DHCP protocol, that's most important for us to know. Then it passes to the presentation layer. The presentation layer has as well, that's responsible for encryption and compression. Then pass it to the session layer, which is usually responsible for session management. Session management, which include the A+A, authentication and authorization. That's the one which allow you to connect to your bank account, whatever it is. If you don't use it for a couple minutes, it terminates automatically. That's the one. Then we have the transport layer, which is layer number 4. Really important, highly important. That's the one which has the end-to-end connectivity. And that's the one which is responsible for carry the weight. We have reliable connection, TCP, unreliable connection, UDP. Then let's move to the layer 3, which is the network layer. The network layer, that's responsible for 2 things, routing and logical IP. We will cover routing in week 3, week 4, and you will see that's why routing is really important when we use OSPF or ERGP or so on, and how it's being routed. You will come to that. Then we come to layer number 2, which is really important layer, and it has a lot of things. But the most important ones we're dealing with, error detection, error correction, flow control, and media access control. Media access control, that's highly important. That's the one. Then finally, we goes to the layer number 1. Layer number 1, usually responsible for translating the 0101 into electromagnetic signals. It depends on what type of end communication you're using. For example, I'm using RJ45, which is the CAT file, the Ethernet. Someone else using Wi-Fi connection, someone else using infrared. That's how it is. So that one translate the 0101 into the used signals, whatever the signal been used. We name the data which move from the top to the bottom based on the message name, based on where it is. If the message still on the application, we still call it data. Then pass down to layer number 4. If you are using TCP protocol, we call that, if you are using TCP protocol, we call it SIG. If you are using UDP, we call it datagram. So when we hear the packet, the segment, whatever, you know where you at, which layer it is. So if you are in application layer, data. UDP, that means we actually talking about layer 4, but we are using UDP. If I'm talking about segment, I am in layer 4 still, but using TCP. If I moved to layer number 3, we call that packets. If we moving to data link, frame. So then bits and bytes. So that one, when we mention something like a packet, that means you are in layer 3. Frame, you are in layer 2, and so on and so on. So when you read something, you don't get confused. That's another approach for explaining the encapsulation. How that encapsulation in a better way shows up. Let me show you animation from my own side. This is the encapsulation. Look at the data, what happened to it, and we will go. This is the data I want sent, or I want to open, whatever it is. That's the data. That's application layer. Then the TCP layer, which is layer number 4, will be added. Then over here, the layer 3 will be added. Then layer 2, which is the Ethernet one. So that one, all of it, we have added some headers, and we send it. We call that encapsulation. When you add headers to the data, your data, we call that encapsulation. You encapsulate something. And it's been sent as in the shape of 0101. When it arrives to the other side, watch that. That's 0101 arrived to the destination. I have the whole frame. Then I'm going to take the Ethernet and I'll move it up. I'm going to remove the IP to move it up. Then I'll take the TCP, move it up. I end up with the data. How that works exactly in terms of example, assume that you are on Facebook and you have typed, for example, hey, what's up? Typing to someone or typing in something on the Facebook. What happened exactly? That's your data. As soon as your data, you hit enter, it will be encapsulated in application. It adds to it, we call that encapsulation, into the header. What's in the header, by the way, just only to understand? What's inside the header? Instructions. It's fields, those field instructions. And each layer has different instruction. So here it is. We add to it the header, the application layer header, and it passed by here. At that time, it's called data. Then pass to the layer number 4. We add the TCP. Then we add the IP. Then we add the MAC address. And up to here, it become a frame. Then we pass it to the physical layer. The physical layer will break it down into 010101. Then pass it to the internet. And the core of the internet, usually routers, if you have studied that, or you still remember that from the prerequisite unit. From here, it goes to the other side. It arrives as in the shape of bits and bytes, 0101. It rebuilt in layer number 2 to become the frame. Then over here, we remove the MAC we remove the IP, we remove the TCP, we remove the HTTP. So the data arrive, only the data. So we start with data, we end up with data. So what the need for all those instructions? Instruction to how to behave through different devices. So if I want to send you the data, I need to make sure of many things. One, the data it's gonna be safe. The data is gonna be routed correctly. The data is gonna be reliable or unreliable, whatever it is. So we have different approach, but the whole thing focus on the data, how this data will take those instructions to be able to go through different devices until it hit the target devices, which is the destination. Are we okay up to here? Any question? No? No. Now let's go back to the Wireshark. Thank you. Okay, so let's go back to the Wireshark. Why we do that? Because like that's in Wireshark, you need to understand the layer first so you can read what's inside the Wireshark, the capture. So if I want to go over here, this is represent exactly one packet, which is that's the get packet, by the way. I can find out here what the data, which actually represent the layers. If you want to see the layers, let me minimize that so you guys can have better view. So what we have exactly here, this is what we usually, I have the get. What do you want to get? Okay, from the HTTP here, it shows me that you tried to visit baidu.com. Okay, so what's the instructions here? What the data you will give me? I told you that the frame, the whole frame, the size, how many bytes, and then from here I can give you extra details about the MAC address. For example, over here, this is the Ethernet. That's the source and that's the destination. That's the MAC address, by the way, for the destination, the ASUS, and that's usually the router or the router, my router. So, and this is my device, my own computer right now. So that's the TP link, or that's the wireless adapter, the one I'm using. So that's the D03745. That's hex, in hex. The destination is over here. That's the source. What type of IP? It's like IP4, IP version 6. It's over here as well. What is the IP address? That's layer number 3. So the Ethernet coming from layer number 2. This one is layer number 3. What's in layer number 3? Okay, we're using IP version 4. What is the source? Which is my computer, 192.168. The destination, which is the remote side, the remote server for Baidu, that's 103.235.46.102. The header length, some extra details if you want to go through that when you study Wireshark. For now, not require much for this lecture, for example. Here, the TCP usually we focus on port number, and in lecture 3, lecture 4, I believe that you will study the sequence acknowledgement. So we will go over how the TCP works, and you will, in basic, sure. So the source port number, it's 51594, and the destination port is 80. 80, the HTTP, the one I send it to the HTTP. And you show here that we see that the sequence, acknowledgement, and so on, the window size, and so on. Hopefully, we will study that, or we will teach you that in this unit in a short brief as well. So layer 2, layer 3, layer 4. That's how it is. That's how it is. Easy as that. Then that's 4, 3, 2. Then the frame itself then goes to the layer number one, which is the physical layer. The question here is how I determine my computers, switches, devices, the IPs. How, if I'm not using IPs, how to determine a device? Which is my device, that mine or yours or whatever in the network? So what we do exactly in that term, we have 3 different identifiers. We can identify a device by IP, which is, I believe that's everybody familiar with that. We can identify a device as well by MAC address, which is the physical address. That's excellent, unique, almost, and it's easy to identify. When it comes to identifying device by ports, we will cover that much because we actually can run multi-ports in one single IP address, which you will see that later on. How to get a data about all your devices in your computer? You're familiar with the command line. So I believe that you can do that with me at the same time. So you can type, for example, ipconfig. That's how it is. You type ipconfig/all. It's going to give you everything. I have many interface in my computer. So many of them actually are virtual device, except this one. That's the one which is, that's the physical one, the TP-Link wireless. As you can see that's the physical address, and that's the FE80, the link local, the IP version, subnet mask, the lease, and so on. That's the IP. I have VMware. I have as well another VMware. I have VirtualBox, don't get me wrong, I have many. Then I have the physical one, sure, which is I'm not connected to at all. The physical one, the Ethernet adapter. So I'm not connected to the physical adapter totally. Can I get the same thing with something else? Yes, we have the PowerShell, which I do recommend you to try those ones the same way I'm trying right now. One of the good thing which is with I'm going to show you, I think it's better. With the PowerShell, you can, as you can see that, it's almost like autofill. So if you just type part of the command, you didn't have to memorize the whole command. So one of the main command to see the details of the MAC addresses, whatever inside, so the git net adapter. So if you type over here, you will find git net adapter. Here it is. Here. What it tells me exactly, you have a Wi-Fi, the TP-Link adapters. You have the Ethernet 5, which is the physical one, the one I told you that I'm not using that one. That's the only 2 physical in my computer, the Wi-Fi and the US adapter, the one I'm using. And here, that's the Ethernet 5. Other than that, those ones are all of it virtual, mostly. So the Cisco Connect and VirtualBox and everything and Kaspersky and whatever, all those ones as it is. That's how to get some of those ones. So if I, let's say here it is. What about if I want to, sometimes when you type commands like that, you end up with many. Many means like, as you can see here. What about if I want only to specify the physical? So what you do exactly, just type physical like this and hit enter, you get the physical only. As you can see, that's the one, that's everything. And as you can see that the Ethernet controller, the type, the model, and everything, if it's Intel or whatever. Just type physical next to it, nothing else. Another approach, which is we go with net IP configuration. Here it is. That one give you extra details about almost everything you have. If I skip those ones for the virtual one and I stick with the last two, which is the physical ones, what I get exactly, the type of the adapter, the IP address on it, the default gateway, then the type sure is connected. This one, as you can see, disconnected. And over here, the type as well. What about if I want extra details? So I can type something like get, that's net IP address. IP address. And we have something called interface else. And over here, you can type Ethernet. So for example, if I hit here, can you see that? But if I type over here, Ethernet, mine is what, I believe 5, if I'm not mistaken. Like this, I get the details, sub details about my Ethernet 5. That's my adapter, the adapter I am having. So what's inside? The same thing. The link local, what's the name, the type of the unicast, IP, away from study here for now, but that's extra details you can get from the Ethernet if you want so. We have another one, which is, I believe that you familiar with the IP config, still work here, perfect. There is no problem with that. What about if I want test connectivity? If I want test connectivity, you familiar with can you ping 8.8.8.8 like that? You familiar with something like this? We have covered that many times. Do we have something better into, and this one, by the way, we send only 4 packets, it come back to us, we calculate the RT and so on. What about if I want more details about the test connections, like about what type of connection we're using, the computer name and everything. As you can see here, we only send 4 packets, come back and tell me that there is a connection or not, and a round time trip. Sure, we have traceroute in which can count for you how many routers and how many hubs between the source and the destination, which we will do in one of the labs. You will do that as well. However, if I run the command, which is you will need that, I believe, in the advanced units. If I use that test connection, what I'm going to come back with, here it is. The computer name, that's my computer name. The remote address that's the remote address, which is we send it to, instead of send it to 8888, it send it to random or a remote device or remote server or remote part of the connection testing. The Wi-Fi, so that's 192. Watch this one. The ping succeed. It's true. So the ping replay details the RTT 45 milliseconds. Here it is. If you go, that's received. The round time trip in milliseconds. The minimum is 5. The maximum is 19, and so on. I here ping the Google. Here it actually take to a remote server automatically. So this one, 45 milliseconds. Okay. What about if I want to, let's test connection. Let's go for here. We send 10 packets, 1, 2, 3, 4, like that. Count. So is that works? Yes. Test the connection. It come back 10, 15, 5, whatever you like. So here, what we actually try to do, we try to find out if I want to find details about my own device, which is the source. Use ipconfig. If you're using Linux, fconfig, it's going to give you a lot of details. If that's not enough, use one of those in the PowerShell, which we, if you want my advice, try to keep those commands in your mind. Keep that. Get the network adapter. It's going to give you details about network adapters. If you have physical, just put the physical. Get the network IP configuration. It's going to give you most of the details about the IP configuration on your device. If you want, sure, sometimes you have many of those ones, especially if you have too many virtualization application on your computer. Then go over here for the test connection. That's another approach. Which one we want to use? It depends. It depends. It depends on the situation you are in. Do you want to get the local devices? Do you want to ping? And ping as well has many approach. But anyway, those the basic and famous command, PowerShell command for entry user computing. So we recommend that to memorize those commands for future use. Up to here, you okay? Up to here, are you okay?
Yes.
Thank you. Okay, so let's go over how we communicate. How devices communicate usually. Well, the famous connection, which is you guys familiar with, and I believe so, the client server. What is the client server exactly if I want to present that? I can take something like that. That's PC, for example, and I can put server over here, and I get them together. Sometimes we put between both of them a cloud to represent that in the shape of client server. And this one is not covered in this unit, in that part of the unit. However, that's the majority of the network. The majority of our used network around the world actually client server. For example, now I'm talking to you from using Zoom, that's a client server. You actually using the CQ model, that's a client server. Yahoo, Gmail, Hotmail, and whatever it is, over 90% of the world communication based on client server. What else we have? What else can be? Well, we have what we call it here, let me see if I can find that. I create you a file here. No, no. Anyway, we can create it with that very easy. So what we do exactly, if I want that peer-to-peer. Peer-to-peer, I think you're familiar with that, and you have done that as well into, if you still remember, peer-to-peer is like this, device to device. If you want to communicate a PC to a PC. So if I want, for example, put in that PC, that's 192.168.10.10, and over here, I'm gonna put 192.10.20. And here it is, just only to see what we do. If I want to ping from here to here, watch that. And here it is. And as you can see that it's successful. Pinging, that's what we call that peer-to-peer. Peer-to-peer, that there is no actual centralized server between. So device to device, as you can see here into the lecture slide, we connect that. That's the crossover cable. If you are attending the campus, we actually have done that physically on the campus to students. So if you don't, just to try. But the cable here, that has to be crossover cable, not normal CAT cable. Two different cables. I believe you study that in the prerequisite unit and you understand the difference. That's if I wanted to send one-to-one. So computer to computer, device to device, switch to switch, whatever it is, we use crossover cable. But this is peer-to-peer, which means that a device, connected device, directly or indirectly, but there is no centralized command. There is no server. And the best option, the best one you can, if you're familiar with something called torrent, that's peer-to-peer. Music sharing, file sharing, whatever sharing, mostly based on peer-to-peer structure. We call that network structure. So peer-to-peer. What else? Well, this is how it works like that in terms of logics. So the computer connect to another computer through the cable, usually the application, then the port, the operating system pass it to the network adapter. The network adapter pass it to the cable in shape of 0101. The same thing. They enter the network card, reverse the operation to the top. What are the other options to communicate? Oh, we using what we call it switch. Sure, we have something called hub, but later on, we in one of the lectures, we will cover the difference between hub and switch. But for now, what exactly the switch? That's the one we prefer to connect it to. How that works exactly, you're familiar with that? Ah, here it is. I believe that's the one as well. Here, that's the one which is I can connect those ones like this. Instead of connecting here, I'm gonna put something like that. That's a switch. And instead of those ones are connected like that, I'm gonna delete that one here. And I will link those ones into here. Here. Let's add another PC. And I'm gonna link here. So what happened exactly? There is no direct link. As you can see that we have the middle device, which connected those ones together. That's 1010. I believe that I mentioned that to you, 192.168.10.10. And over here, we put that 192.168.10.20. And I'm gonna configure this one, 192.168.10.30. Let me go inside that device and put the IP. That's 192.168.10.30, right? Here it is, here. Already? Yes, already. So let's ping from one device to another. Let's delete that first. So to become clean. And let me ping from 1010. I want to ping 1030. And let's see how that works. So it gone through the switch. No direct connection between both of them. Here it is. And as you can see, that is successful. There is one thing which I wanted to understand. The second, we have client server. We have peer-to-peer. Then what we have here, as you can see that this is the WAN, the connection through the WAN. When we have a WAN connection through, so if I want to go through the WAN connection, what we do exactly? Sure, it's like if I want to send data from here to, let's say, let me just show you. If I want to use, I'm going to use the tracer. For example, let's go for, I want to find out how many hubs, how many routers to get to the Google. So I want to find how many routers from my computer here until I get 8.8.8.8, whatever it is. So it will list for me the tracer every time it passes by a router or a device. It's going to give me an entry. How many? 7, as you can see that. So anyway, when a device sends a data through the routers, unfortunately, routers are not all equal in terms of technology, let's say. Something old, something brand new, something very advanced, something is not. Something from that company, something from different companies. Yes, we have standards and standardization and everything, and they work together, yes. But here is a problem. We have something called MTU. When you send a data from this router, for example, if I want to send a data to cross from that router to that router, for example, maybe this one very advanced, maybe this not, maybe this low, whatever it is. So what happened exactly here? We have something called MTU, the maximum transmission unit. What is that exactly? If I have a big file, which is, let's say, 10 gig, or let's say take something small, 10 meg, the maximum transmission unit, which is the data can carry it. Imagine it's like if you have a big transportation and you want to transport something, that's a 10 ton. However, your truck cannot take more than 1.5 ton. So you need to multiply and find out how many trucks I will need. Similar to that concept apply. What happened exactly? We have something called MTU. The MTU exactly 15, 18 bytes. We summarize that to students and everybody. You will find it in every textbook, 1500. 1500 byte, which is 1.5 meg. So if I have a file which is 10 meg, what I need to do, you not do, but the device will do. So what they do exactly, they break this one into 1.5, 1.5, 1.5, 1.5, and so on until whatever the leftover at the end. Really? Yes. Okay, so if I am sending a data, I'm sending you a data. You break it down. Yes, I break it down. Okay, so when it arrives to the other side, how I know that, how the device knows that, how to rebuild it again. Here it is. Every one of them has instructions, which has the source destination, the source and the source IP, the destination IP, and so on. And each one has a signal. We call that flag. Flag which means that you need to rebuild. So when they, which called reassemble, I believe I can have the Wireshark. Watch that. Can you see this one? That's the data which came back from Baidu, the page. So why it has like that? Why keep going like that? Because what we have exactly, we have segments, which means that you have a data more than 1.5 meg, which is something small. So I need to send it to you. I break it down into 1.5, 1.5, 1.5, and it has something called sequence inside and flag. And sure, source and destination. When it arrives to the other side, imagine I'm sending this one here. It will break it down into smaller pieces like this. And it has, each one has source, destination, it has flags, it has sequence. When it arrives to the other side, which is, let's say, this is the destination, that router will look at those devices. What is the sequence? What is the acknowledgement? Do I have flag? Do I have sequence of that file? And can I rebuild them? Rebuild. And they start to rebuild. That router will rebuild the whole structure as it is, the whole file. This is your file, for example, file 1. This is all pieces. Here it will take the pieces like that, and it will rebuild it as a file one as it is, based on the sequence, the flags, and so on. Okay, what about if I'm sending that and one of those packets, whatever, gone? We lost it. The TCP, if you are using TCP, will resend the missing one because we have reliable connection, guaranteed delivery of your connection or your delivery or your file. The breaking down these pieces, we call it in two different layers: fragmentation, or defragmentation. And in another, which is within the TCP layer, segmentation. There is a difference between MTU and something called MSS. Away from study for now, let's make it to another lecture. But for now, you need to understand that when the data pass by routers, not all the routers can transfer even the 1500. Really, yeah. So even some router, they cannot transfer or they cannot accept a packet of 1500. Yes, we have something like that. And at that time, those router will talk to each other and they agree on what they both can send. So one of the router can send 1200. That router only 900. I cannot accept more than 900. They will agree on 900. And at that time, they will start to break in the pieces. So I send it from my router, 1500, 1500, 1500. When it come to that router will break it down again after rebuild it, break it down again to 900, 900, 900, like that. And here is the other surprise. Even your file will not take one direction to arrive to the other side. What you mean by that? Watch this one. So if I have my device here, I want to send a data through multi-routers here. And this is the destination. That's destination, that's source, and I want to send the data. That's my file, right? Here it is. That's my file. So what this router, which is our number one, will do, router one will do, break down this one to pieces. Then what? Believe it or not, one of those will go this direction. And maybe the second one go through that direction. And maybe the third one go through that direction. Really. That's how it is. That's how it is. And even if I connect those ones, this one maybe come over here, then take that direction here, then take that direction here. Why it does that? You will understand that when we come to something called metrics later on. So the defragmentation or segmentation or routing the file or the packets. One, the file usually being break down into pieces, and that pieces has sequence, and those sequence, when it been sent, at the end, the arrival device rebuild them again. That's it. That's it. Even those pieces, they may, it doesn't have to be, but they may take different direction over different router, different whatever. When they arrive to the other side will rebuild them again. Make sense? Make sense. Now, do you have any question? That's mostly what we need to cover for today, by the way. Do you have any question? No questions. Really? So everything is clear or everything is not clear? All right, ladies and gentlemen, if everything is clear and you don't have any question, feel free, have a good one, and I'll see you next week. And feel free to email me as well. If you have any question, anything, email me. I'll be more than happy to reply back to you. Have a good one, and I'll see you next week.